here a N-terminal his-tagged protein. What is a his-tagged protein? And so, for protein purification purposes, what we do is we take, like if this is a protein, gene of the protein, we add his tag. What is his tag? His tag is a 6 times repeated histidine. Okay, six times repeated histidine is added on the, say, suppose the N terminal or the C terminal region of the protein. So when we want to purify this protein, we take a nickel NTA column. This nickel NTA column, which has nickel. So nickel, what will happen is that this nickel and this histidine, via its imidazole rings, it will attach with the nickel. Okay? It will attach with the nickel and it will bind to the column. And the other proteins which do not have the histidine tag, they will not bind to the column, and that is how you can separate your protein of interest. Okay, so that so now they have taken an N-terminal histag protein of molecular weight 40 kilodalton. Okay, the total molecular weight of the protein is 40 kilodalton, and it was purified using nickel NTA column. This protein was subjected to SDS page. Now they have done an SDS page with the protein. A Western blot of the same using anti-His antibodies is shown. So here you can see there is a band at 40 kilodalton also, and there is a band at 20 kilodalton also. So what does this mean? So does this mean that the protein has broken down, or what is happening? Which one of the following interpretations is correct? Only the his tag of the protein got removed. The protein forms oligomers. The purified protein sample is homogeneous, and the protein has stable N-terminal 20 kilodalton domain. So which one do you think is the correct option? So again, if you go through the options, only the his tag of the protein got removed. Even if the his tag of the protein is removed, then it will not show up as a 20 kilodalton band. It will be even less than that, 2 or 3 kilodalton max. Okay, it will be it will not be visible as a 20 kilodalton band. So this option is wrong. The protein forms oligomers. If the protein formed oligomers means what? More than more than two subunits will be there. But there are not more than two subunits, and only you can see 40 and 20. So maximum it can form a dimer, even if we take. So 20 kilodalton can form a dimer and it can form a 40 kilodalton protein. So oligomer is out of question. If it was the protein forms a dimer, then it would have been correct. The purified protein sample is homogeneous. If the purified protein sample was homogeneous, then we would have gotten a single band, which is not the case. So is also false. The protein has a stable N-terminal 20 kilodalton domain. Now, the his tag is attached to the N-terminal. So, that if a 20 kilodalton domain is stable and it is attached with the his tag, then only this band will show up in the Western blot, right? So, this option can be correct, that the protein has a stable 20 kilodalton domain. That is why this portion, the N-terminal portion, along with the his tag, that is showing up in the gel, right? And another, this total protein is also getting shown along with the 20 kilodalton stable subunit, which has the N-terminal his tag. That is why both of the subunits are getting shown. If the his tag was in the C terminal, then perhaps this band would not have uh, like if the his tag was over here, the C term, then we would not have gotten this band. Okay, because this part is stable, and this part will not show without the his tag because we are proving with his antibodies, not the protein antibodies. Okay. So the option correct is the protein has a stable N-terminal domain of 20 kilodalton.